Hi, this is Unit 4, Day 1. We're working on our unit called Lines, and this day is all about slope. So we're going to look at some word problems. If we want to find the slope given a real-life scenario, usually what we're thinking about, slope, is that it is the rate of change. So we're trying to figure out some sort of a rate of change. So in this case, a climber is on a hike. After 2 hours, he has an altitude of 400 feet. After 6 hours, he has an altitude of 700 feet. So what is the rate of change? So I'm going to think for a moment, and it looks like his altitude depends on the amount of time he has been hiking. So if altitude or feet is the dependent variable, that means that's going to be in my numerator, right? Because slope is always the change in y over the change in x. So y is the dependent variable, height depends on time. All right, so what I'm going to think about is, what do I know? If I have time and then height, if I imagine I'm writing this out like this, after 2 hours, he has a height of 400 feet. After 6 hours, he has a height of 700 feet. Okay, so that's a way that I can be thinking about this, and those, of course, I can turn into ordered pairs. I'm now going to say 2, 400 is one of my ordered pairs, 6, 700 is the other ordered pair. Change in y is going to be 700 minus 400, and that's over x. Change in x, 6 minus 2. So I get 300 over 4, which simplifies to 75. Okay, 75 is the slope. 75 is my rate. If I think about this, I have feet in my numerator, right? And I have time in hours in my denominator. So this is 75 feet per hour. And that makes sense if we're talking about a rate, 75 feet per hour. Okay, so let's look at scenario 2. We have a scuba diver. He's 30 feet below the surface, so we're probably going to have a negative if we're talking about below. He's 30 feet below the surface of the water 10 seconds after he enters the water, and 100 feet below after 40 seconds. So let's think about what depends on the other thing. His depth depends on how many seconds he's been in the water, right? So his depth is the dependent variable. So we're going to say again, time is the x and depth is the y. Okay, so he is 30 feet below, so he is negative 30 feet, and that's at 10 seconds. And at 40 seconds, he is 100 feet below. Okay, and of course you're thinking, here's the water, here's the scuba diver, he's got his legs that way, and he's got a mask and a snorkel. So he's happy, and he's going down below the surface. That's why we have a negative. Okay. So, what is the scuba diver's rate of change? I want to know, what is the change in depth over the change in time? What is the rate of change? So I'm going to set myself up, 10, negative 30, side by side with 40, negative 100, negative 100 minus negative 30. Don't lose your negatives. All over 40 minus 10. I know that this means negative 100 plus 30, so I have negative 70 over 40 minus 10 is 30. This is negative 7/3. If I imagine what that looks like as a slope, it's going to be a downhill slope. It's a negative slope, right? So I also know that time is in seconds this time, and depth is in feet. So I know I am going down 7 feet per every 3 seconds. So there's our answer there. Okay, so in this problem, Ms. Shin is paying off her car loan at a constant rate. The graph shows her loan balance as a function of time, and notice it's a negative slope. We see that the amount she owes, the balance that's left, is going down. That's what we want. Okay, so at what rate is her loan balance decreasing? Let's find out. We can find any 2 points that we are willing to work with. So that looks like a good point right there. I'm looking for points that are pretty solidly on the axis. of one of the grids there. Okay, and looking at this graph, a lot of times I like to just wump down and wump over, but since my scale, this is 500, 1,000, 1,500, since it's not 1-to-1, these down here on the bottom are 2, 4, 6, 8. Since it's not 1-to-1, I'm actually going to write out my ordered pairs. I think that's safer to do. So this point that I've chosen is at 4, 6,000. This point here that I've chosen is at 8, 5,000. So I have 2 points. Remember, you can choose any 2 points you want to choose. So if I put these side by side, I'm going to say 5,000 minus 6,000 is negative 1,000, and 8 minus 4 is 4. Okay, this is my slope. Remember, slope is always m. If I simplify that, that equals negative 250. So we expect that her car loan balance, the amount she owes, is going down by $250 every month. One of the handy things about having a graph like this is if I know the relationship and I have something on a graph, I can imagine that I want to know what will my balance be at 20 months. Maybe for some reason I want to know that. If I come here to 20 months, I can dot my way up to see where did I hit my line. I hit my graph, my line right there, and I'm coming on over, and I'll be at $2,000 left. At 20 months, I will only owe $2,000. So graphs do come in handy for that sort of thing. All right. We know that slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And remember, that's exactly what I'm doing when I use my rainbow arcs here. This is y sub 2 minus y sub 1 in the numerator, x sub 2 minus x sub 1. Okay, so every single time that is true, our slope equals the change in y over the change in x. So we can find a missing value in here if we want to. Here's an example. Maybe I had ordered pairs written out on a piece of paper and somebody spilled their cereal on there and I can't read the first x. I don't know what that says. It's a big glob. So I need to find out what was the first x value in my first ordered pair. Okay, this might be x sub 1, y sub 1. We're going to call that my first point. This is x sub 2, y sub 2. That's my second point. I'm just going to plug in what I know. Y sub 2 is negative 3. Minus y sub 1 is 6. That is all over x sub 2, which is 10, minus x sub 1. Here's what I know. I don't know. I don't know that. Something messed up my paper and I can't read it. So it's a variable, right? But I know that the whole slope is negative 3 halves. I know that because I was told the slope equals negative 3 halves. So now I'm going to just do some math. Negative 3 minus 6 is negative 9. 10 minus x I can't solve. Okay, so I have negative 9 over 10 minus x equals negative 3 over 2. I have two ways to solve this problem. I can solve it using proportions, which is the way I'm going to show you first, and then we'll talk about the second way. Okay, proportions means that I say the bottom one denominator times the other numerator, and I set it equal to the other numerator times the other denominator. So I'm going to say negative 3 times 10 minus x equals the other two things multiplied together, negative 9 times 2. Okay, this is negative 30 plus 3x. I use distributive property, and it equals negative 18. Add 30 to each side, and I get 3x equals 12, and x equals 4. Whoops, you can't see my writing. I'm so sorry. There. Negative 30 plus 3x equals negative 18. Add 30 to each side, and I get 3x equals 12, and divide each side by 3, and I get x equals 4. The missing value then is 4. This ordered pair should be 4, 6. That's what we were missing, was just the 4. Okay, another way to do this problem, if you want to, we know that we have negative 3 minus 6 is negative 9 over 10 minus x equals negative 3 halves. If you can see that there is something obvious happening here, we can say negative 3 times 3 going this way equals negative 9. And I know 2 times 3 then has to equal 10 minus x. Do you see that? Negative 3 times 3 equals negative 9. And if I multiply the numerator times 3, then I have to multiply my denominator times 3. That means that 2 times 3, which is 6, equals 10 minus x. Okay, I'm going to subtract 10 from each side. So I have negative 4 equals negative x. Multiply each side by negative 1, and I get 4 equals x. Okay, so either way, you're going to find out that x equals 4. And I'll slide everything over so you can see everything all at once. Either one of those methods is totally fine. Okay, let's see if we can find another missing element. We have ordered pairs 3y and 1, 9. So we don't know that number, what number goes in there. We know the slope is negative 5 halves. All right, so I know y sub 2 minus y sub 1, that's 9 minus some unknown number, over x sub 2 minus x sub 1, so that's 1 minus 3. That has to equal negative 5 halves. I know that because the slope equals negative 5 halves. Let's do the math we can. 9 minus y, I can't fix. 9 minus y. 1 minus 3 is negative 2, and that equals negative 5 over 2. Okay, let's think about this one. I can cross multiply if I want to, but I'm not going to because I know that negative 5 over 2 is equal to 5 over negative 2. Negative 5 over 2 equals 5 over negative 2. So this is a way to solve this problem. My denominators are the same, so my numerators must be equivalent as well. So I know that 9 minus y equals 5. I will subtract 9 from each side, and I get negative y equals negative 4, which means y equals 4. My missing number is 4. My ordered pair should be 3, 4. I know that y equals 4. And you can always now find the slope knowing that you found that ordered pair. Okay, if you're not comfortable with how I did that, let's come back and we'll use the cross multiply method. Okay, 9 minus y equals negative 5. 1 minus 3 equals 2. So I'm going to rewrite this. It's 9 minus y over negative 2. I just said 1 minus 3 is negative 2. That equals negative 5 over 2. If I cross multiply, I have negative 2 times negative 5 equals, cross multiply, 9 minus y times 2. I'm going to write it like this just because I like that better for my distributive property. So I have negative 2 times negative 5 is positive 10. That equals 18 minus 2y. Remember, we're using distributive property. And so I'll subtract 18 from each side. I get negative 18 equals negative 2y. And now I'll divide each side by negative 2, but this time I get 9. Something has gone wrong. I see what's gone wrong. Forgive me. Last time I checked, negative 18 and 10 is negative 8. That'll work much better. Negative 8 divided by negative 2 is positive 4. 4 equals y, and that's the number that we were expecting. Sorry about that. Negative 18 plus 10 is negative 8, not negative 18. Okay, number 3. I have two ordered pairs, 3, 5, and x, 2, and the slope is undefined. What does that mean to me? If change in y over change in x is undefined, my change in x, my denominator has to be 0, right? Has to be 0. That's what it means if it's undefined. So I know x sub 2 minus x sub 1 has to be 0. If I know that's true, x sub 2 minus x sub 1 has to be 0. So x minus 3 has to be 0. X has to be 3. I already know that. But if we want to plug everything in, we can do that. So I'm going to say y sub 2 is 2 minus y sub 1 is 5 over x sub 2, that's x, minus x sub 1, which is 3. So I have negative 3 over x minus 3 has to equal something over 0. Again, we can just say -3 because that is the change in y that we had over 0. My numerators are the same. I have -3 in both numerators, x minus 3, and 0 in my denominators. I know that x minus 3 must equal 0, so if I add 3 to each side, x has to equal 3. That is my missing number. So this ordered pair would be 3, 2, x equals 3.